Hello friends, welcome to Geometric Dimensioning and Tolerancing Lecture 1. There will be 8 to 10 lectures. It will take you from basic understanding of Gd&T to advanced level of Gd&T. This particular lecture will cover what is Gd&T, why it is needed, geometric dimensioning, tolerancing, various myths in Gd&T and various fits. Based on we define geometric dimensioning and tolerancing.
First question in geometric dimensioning and tolerancing is what is Gd&T? Father asked his daughter, what kind of husband you need? She told,
he should be smart looking.
Amrish Puri from Loha movie came and told, I am smart. Oops. Need geometry control now. Then she told,
looks like Hrithik Roshan.
exit not possible. Define some tolerances. If not Hrithik, Herman is okay. This is exactly done by Gd&T in engineering design. Same example is shown over here. If we give dimensions without geometric control, it can be manufactured the shown distorted shape with all the dimension. If you go ahead and measure on CMM, all the dimensions are achieved, but form is not controlled. So that's why geometric tolerancing needed.
Gd&T can be divided into two parts. One is geometric dimensioning and other is geometric tolerancing. So geometric tolerancing depends upon geometric dimensioning. What is the scheme of dimensioning we are using in our drawing for our component that is going to affect tolerancing, even geometric tolerancing. So let's discuss few dimensioning schemes.
Shown are most commonly used dimensioning scheme. First one is baseline dimension. In that all the dimensions are defined a single baseline. Second one is chain dimensioning. In that all the features are important and defined individually. And another is combined dimensioning. In that the required feature to be controlled are dimensioned. And fourth one is dimensioning by coordinates. So this is geometric dimensioning scheme.
Let's discuss how geometric dimensioning affects geometric tolerancing or tolerancing. And let's find out what is tolerancing feature. Suppose this is two scheme of dimensioning. First one is chain dimensioning. In chain dimensioning, each individual feature is defined by dimensioning and overall length is not given. So let's find out what is overall length in this case. So it will be 25. But what would be tolerance on that overall length? That is 1, 2, 3, 4, 5 plus or minus 5. So this overall length is called as tolerancing feature, where all the dimensions tolerances are going to be dumped on a single feature. So if I want to control overall length also within some limit, I need to provide some title tolerances over here. Let's discuss in this case. This is mixed kind of dimensioning. In this I have defined the important features like this feature, this and this one. I have defined 5 plus or minus 1. Then overall length is also given, that is 25 plus or minus 1. Then what about this feature that I have left? That will be around 5 plus or minus 5. If I dump all the tolerances on this feature, this will be 5 plus or minus 5. So in worst case scenario, this feature thickness would be 0. So that is how geometric dimensioning affects the geometric tolerancing and tolerancing both.
Let's discuss various types of fits.
In clearance fit, suppose this is hole diameters and this is shaft diameter. In this zone represents the tolerancing zone on shaft and this zone represents tolerancing zone on hole. So in worst case scenario, if shaft is manufactured of bigger diameter and hole is manufactured of smaller diameter, in that case also for clearance fit, the diameter of shaft should be smaller than the diameter of hole. So maximum shaft size should be always less than minimum hole size. For interference fit, minimum shaft size should always be greater than maximum size of hole. Then we are going to get interference fit. Let's discuss transition fit. Transition fit is a kind of fit in which we are going to get sliding fit, interference fit and clearance fit all. So suppose these are the tolerance zone on hole and shaft, and hole is manufactured at its smallest limit, that is smallest diameter of hole, and shaft is manufactured somewhere here, that is near largest size of shaft. So we are going to get kind of, when we will assemble this, we are going to get interference fit. But suppose hole is made bigger and shaft is made of its smallest dimension, that is smallest diameter of shaft, then we are going to get a clearance fit. So accordingly, in transition fit, we can get sliding fit, interference fit and clearance fit.
Let's discuss about various myths in Gd&T, and first myth is dimensioning and tolerancing are separate step.
Geometric dimensioning and tolerancing are not separate steps. We have to be careful while dimensioning in drawing. It is going to affect our tolerancing values and system. So suppose this is a component and this is another component and we are going to assemble it. And in first scenario, this is the face of contact. Then how should we locate these holes? Because while after assembling, we are going to assemble a pin through these two holes. So if these two are the face of contacts, we should always give hole dimension from here to here and this hole dimension from here to here, because these are face of contact. We are trying to reduce dimensions in loop diagram. Same way, suppose this is the face of contact. These both faces are going to be in contact. Then we should define these holes location from those faces. So while dimensioning in drawing, we need to take care of these things, how it is going to assemble. Otherwise, there will be more dimension in our loop diagram in stack up analysis and it will affect the tolerancing system. So both dimensioning and tolerancing are simultaneous steps. We have to perform it together.
Second myth is GTOL should be given on critical parts only, not on simple component, simple parts.
Let's discuss why we should define geometric tolerancing in simple component also. Suppose this is the component and we have dimension it from its age is 5 plus or minus 1, 5 plus or minus 1. So what will be the tolerance zone? The tolerance zone would be rectangular one where axis can shift 1 mm here and 1 mm here, that is 2 mm, 1 mm above and 1 mm down, that is 2 mm. So this is rectangular tolerance zone in this case of dimensioning. Suppose we have made basic these dimension and we have defined 2 positional tolerance on the axis of hole. So its axis can move in 2 diameter all around. The diameter will be 2 So this is rectangular kind of thing and this is circular. So if I draw rectangular tolerance zone in it, we can see that these zone are additional tolerance we are providing on this hole, whereas this hole was more tighter. So this is difference between geometric tolerancing and simple tolerancing. In simple tolerancing, the zone is rectangular one, and in geometric tolerancing, the zone is circular one, and where it provides more additional tolerances.
Next myth is application of GTOL takes much time. It is absolutely incorrect. If you know geometric tolerancing and if you have studied the assembly properly, then it can be given along with the dimensioning while you are drawing, while you are working on drawing. So it's not it is not like it will take much time. Next myth is GTOL increases product cost. It's not if it is mass production, because GTOL slightly increases manufacturing and inspection cost, but it controls on rejection. So it reduces the production cost in case of mass production. Myth in Gd&T is like it improves design. No, it's not. It is absolutely incorrect. Gd&T is a tool with which a designer controls the drawing. He communicates with manufacturing, so it can be manufactured in a required shape and geometry. So Gd&T does a control, not improves design.
So this was lecture 1 for basic of geometric dimensioning and tolerancing. In coming lecture, we will learn various type of geometric tolerances. Thank you.